All right, so this says the height of a baseball in feet is modeled by the function h given by the graph shown. So this is what the graph that models the height of the baseball looks like. And on our x-axis, we're noticing time in seconds. And on our y-axis, we have distance above ground in feet. So one of the first things we are asked to respond to, or the question that we're asked is, when does the baseball reach its maximum height? And when we think about maximum height, we're going to think about the highest point on our graph, which is round about here. So the highest point on the graph that occurs at a time of 2 seconds. So what we notice is that the ball reaches its maximum height at about 2 minutes. So that's the time. And then the second question is about how high is the height of the baseball at its maximum height. And we can see that it's a little bit above 60 feet. You notice the curve is just slightly above 60. So we would say we're estimating that the ball is about 60 feet high at its maximum height, or a little bit above 60 feet high. If you said that, that's fine. And then the third part of what you're asked to do for this question is to say when the ball hits the ground. Now, the ball will be on the ground when the distance above the ground is 0. So that occurs in between 3 and 4 seconds. So that is occurring right at this point. So we could say just before 4 seconds or a little bit after 3 seconds. This is all about estimation, but it's understanding the important features of our graph. So it's going to hit the ground when it's touching the x-axis. So it's a little bit less than 4 seconds. That's when the ball hits the ground.